Find where the line y equals 8 minus x is closest to the point 0, 0. Okay, let's start there. You might remember that there's a distance formula. The distance between 2 points, x, y, and x naught, y naught, is given right here. Now we can just call that d perhaps. And in this example, we can take one point to be x, y, and the other point is going to be, at least in this first part, 0, 0. So this distance is going to simplify quite a bit. Okay, now there's a trick here. I don't necessarily want to take a derivative of a function that has a square root in it if I don't have to. So with some of these distance problems, instead of minimizing the distance d, we can often minimize the distance d squared, which is essentially the same thing. So instead of minimizing this function above, we're going to minimize the square of this function above, which looks a lot simpler. Okay, cool. So again, this is a function with two variables in it, and we can't deal with that in Calculus 1. Calculus 3, yes. But as for right now, we need this to be a function of one variable before we can minimize it. So what we can do is take this equation up here for y and plug it in right there. And we get x squared plus 8 minus x, that quantity squared, which we can do a little bit of foiling to reduce, which then simplifies. And now for the first part of this problem, this is the function that we need to minimize. So what we have here is a formula for the square of the distance between this line that's given here and the point 0, 0. We need to minimize that distance, so we need to take a derivative and set it equal to 0 to find critical points. I don't know about this notation here, but I'll just say the first derivative of this d squared looks like that. The derivative is 4x minus 16 either way, and we're going to set that derivative equal to 0. And if you solve that simple equation, you get x equals 4. Now this gives us the x value on the graph where this line here is closest to the point 0, 0. But we also need a y value, so we will just take this x value here and plug it into the equation that relates x and y. Right up here, we will get y equals 8 minus x, which is 4. And that gives us y equals 4. So the answer to the first part of the problem is just going to be a point 4, 4. And that is the point on the given line that happens to be closest to the origin, 0, 0. Now I'm going to move this right down here because we are going to do this problem all over again, but not with the point 0, 0, with the point 1, 1. So maybe I can squeeze it in over here. The distance between the point 1, 1 and some random point xy looks like this right here. Of course, we don't want to minimize this function. We want to minimize the distance squared because it's going to be a lot easier to do. And again, this is a function with two variables, and we need it to be a function of one variable in order to minimize it in Calculus 1. So we are going to take the line given, 8 minus x, and plug that in for y right here. A little bit of a simplification leads us to foiling and combining like terms. Okay, so this function right here represents the square of the distance between the given line and the point 1, 1. If we want to minimize that distance, we need to take a first derivative and set it equal to 0. Okay, I didn't actually see that coming, but maybe I should have. With the given function that I have and the given numbers, I'm getting the same exact point, x equals 4, y equals 4. And actually a graph of this situation is going to reveal why that happened. But if numbers were just slightly different here, this would not be the case. This is not a general result. We won't get the same answer every time in this problem. But okay, as for these numbers, that question is answered.